two secondary school students were killed when their motorcycle struck a
A
pothole
child
and
was killed
skidded
in a
along
five-car
Jalan
accident
Sengkang Felda
believed to
in
have been
Bangka
caused by
Tenggara
potholes
on
in
Friday
September.
morning.
One of those road hazards
It is
leading to
believed
an
that the
accident
accident
involving a
occurred after
motorcycle.
one of the
Road conditions play a crucial role in ensuring public safety, yet potholes remain one of the most common and dangerous issues on Malaysian roads. They can cause vehicles to lose control, damage tires or suspensions, and in many cases, lead to severe accidents. In Malaysia, from 2018 to 2020, Malaysia reported 223 road accidents caused by road defects, including potholes, and of the total cases, 148 were fatal and 34 caused serious injuries. Even in recent years, from 2022 to July 2024, 181 pothole-related accidents were reported, including 23 deaths. To address this, we propose a smart, AI-powered pothole detection and depth estimation system using the ESP32 CAM microcontroller to send an early alert to the driver. This system detects potholes in real time, estimates their depth using a laser, identifies whether the pothole is dry or water-filled and provides non-distracting alerts to the driver using LED lights and a buzzer. The hardware components involved are ESP32 CAM, used to capture road images and run AI models, and the laser module, which will project an invisible laser line over potholes for depth analysis. The LED indicators will show the color red or green to show pothole severity, then the buzzer will provide the audio alert for dangerous potholes. In order to maintain the power supply of the systems, it will be connected to the vehicle battery. The software components involved are AI models such as YOLO Nano or MobiLenet for lightweight object detection and to differentiate between dry and water-filled potholes. It also includes the mathematical formula to estimate pothole depth based on laser deformation. How does the systems works in real time? It will work, as the ESP32 CAM continuously captures road images around 7 to 10 meters ahead to give the driver enough time to respond once the potholes are detected. A lightweight AI model detects potholes in the images from the database according to the diameter or size, reflection, and pothole texture patterns. If the pothole is small, it is ignored. If it is large, the system continues and then determines if the pothole is dry or filled with water. The laser module activates and projects a line over the pothole. The camera analyses how the laser line deforms. Based on the deformation, the depth is calculated using trigonometry for dry potholes and a refractive correction formula for wet ones. If the pothole is deep and dangerous, the system triggers a red LED and buzzer to alert drivers about the road condition. If it is shallow, it shows a green LED only. Lastly, the system continues scanning as the vehicle moves. For pothole depth calculation, it will be separated into two parts. Firstly, dry potholes. For dry potholes, once the AI detects the potholes, the laser will start to scan the potholes and do the calculation to identify the depth of the potholes. The position of the ESP CAM and the laser will be considered, and their angle will be fixed for calculation purposes. In the calculation, some value will be derived from the other formula, which includes the dry potholes displacement, the length of the line segment and the depth. The displacement of the dry potholes will be used, and the trigonometry calculation from the angle of the camera and laser. The final calculation results will be compared with the threshold value and provide the related response to the next step. Secondly, water-filled potholes. In the calculation, some value will be derived from the other formula. This includes the utilization of Snell's law to identify the refractive index of water. After deriving and combining several formulas, the depth can be obtained. As the formula is difficult to contain the exact depth value, the simplification of the value can be referred to the graphical value and the relationship between the camera and to identify the depth. For the alert output and logic, the microcontroller will detect the road images around 7 to 10 meters ahead. Once the deep and big potholes are detected, the red light and buzzer will be turned on. For shallow or small potholes, the green LED will light up, indicating the road pothole condition is quite safe for drivers to pass through. After passing through the potholes, the systems will keep scanning and provide the output again once another pothole is detected. In this system, water-filled is also under consideration because the water can mask the true depth and severity of the pothole underneath. This can mislead drivers into thinking it's safe to drive over, which can lead to accidents, tire damage, or even loss of control. In conclusion, it makes it ideal for installation at the dashcam position inside the vehicle. By placing the system near the windshield, similar to how dashcams are mounted, and the system can capture a clear view of the road ahead. This placement ensures effective real-time detection without obstructing the driver's view. Thus, overall, this able to deliver a smart and effective system for real-time potholes detection and depth estimation to improve the road safety by involving the hardware components such as ESP32 CAM microcontroller, laser, LED, and buzzer and software components such as AI models YOLO or MobiLenet detection to clearly differentiate the dry and water-filled pothole to do the correct mathematical calculation and provide the alert alarm to the drivers and giving drivers enough time to respond safely.